Hello my friends, I hope y'all are having a great Sunday afternoon. The picture coming up is the final product of one of the castings that are done here at Windy Hill Foundry, and it was donated by Aaron Durda. He won this straight edge at the Barzy Industrial. Here we are molding up the Rucker 12-inch straight edge, and I believe it was back in August of 2020. Keith Rucker sent me the original hardwood pattern. It was made out of mahogany. And from there, I made several attempts to get some good quality aluminum production patterns made off of that, which you see here. This is the final revision of them, or the final attempt. I also went ahead and cast the runner system and the gates, so all that's already done. I don't have to manually cut anything except for the runner connecting the sprue into that. I've had my issues with these throughout the last year, particularly right on the very thin lip of the shoulder. I made several that were bad there at first. To be honest with you, I've scrapped a lot of 12-inch straight edges over this year to get to this point. But this particular lip was so thin it wouldn't fill, and you're going to see it here in a second. I checked the original pattern and it looked fine, and I kept re-examining the aluminum pattern here, and I actually, under careful inspection, found my issue, and it was just super thin right there. I ended up building it out with filler and sanding it back down, but this is the spot right here, and it was causing me a headache on every mold. I would have to scrap out one casting per two, so 50% failure rate. I got that resolved, I thought, and I went about casting, and every once in a while I would hit another string of bad luck right there with that particular spot. What it pertains to is the casting's thickness in that cross section. It's so thin that what is happening, if I don't get that iron almost at 3,000 degrees before I pour it, it is not going to fill that void. And usually my temps are probably running around 2,800, 2,850, and which is suitable for just about any casting. I've never had an issue with it at that temperature. But for this particular pattern, you've got to get it several hundred degrees hotter, which is damaging to the furnace. You have to do more patchwork, more maintenance to it to keep it going as you pour this kind of temp. But you know, it's slowly getting there. It's been a fight, and because I'm so far behind on these, I have pretty much had to shut down on all one-off jobs for the rest of this year. I do hope you guys understand. This has been pressing from day one, and it's very important that we knock these out. So that's what I'm going to be focused on the next month and a half to 2 months is doing everything I can to get these. I don't make much money when I'm scrapping a bunch of stuff out, so I have to stay focused. One of the things I plan to do on the next attempt is go ahead and build up the thickness of these plates by adding a layer of my good old faithful foil tape to the back side of these patterns, and I'll keep repeating that process until I am running into no problems whatsoever with the casting filling. Now, I had another issue going on with these as well. On the cope side half of the pattern, they were so heavy they were falling out of the cope almost every time I'd go to pull the mold apart. And you talk about mad. There was a side of me you'll never see on YouTube. So I knew I had to do something about that, and it wasn't until recently, because that thickness of the lip has been such a the top priority of my issues, trying to get that resolved. I'm just now getting around to fixing the second issue. And that was to insert pins into the end of these to anchor into that bed of sand. And if you look right here, as I rotate it, you'll see a hole going in there at almost a 45-degree angle. And I have a bullet-shaped pin that'll go in that hole, and it'll protrude out of the end of that casting into the sand bed up under, or in this case, over the parting line of the mold, and anchor it in place. The only thing I've got to remember is to remove these pins before I try to pull a pattern, or I'm going to have a huge chunk of sand on each end break off with it. So far, these have been working, and it's been such a recent addition. I haven't even announced it to Keith. I haven't had a chance to fill him in on that, so he'll see it here on the video. The risers I'm going to use here are made out of polyethylene resin. I had a set of really nice wooden ones, a set of 4, and one mysteriously disappeared. I don't know how. But so it was just quicker to go ahead and pour these in resin, be done with it. And they actually come out of the sand very smooth. I like the way they handle, so. But yeah, we've had a lot going on between furnace issues, molding, or the molar issues, events that I've had to be at that I'm obligated to every year, along with several road trips to go get supplies that were donated or purchased. And as you guys know, I was in Manassas, Virginia a month ago, and then just this week of Thanksgiving, we went to my in-laws for that in Iowa, and then from there, I had purchased several months ago a rotophase phase converter up in, well, near St. Paul, Minnesota. So I decided to just go ahead and kill 2 birds with 1 stone. So we took the white suspicious van up there and loaded them up. And I got back after, I think I was up there 5 days. While I was up there, I was going through my emails, and this one particular subscriber had asked me some questions on a 100-year-old architectural drawing that he was reproducing on casting methods for that. And as I looked at his city address down at the bottom of the email, it cited that he lived in Rochester, Minnesota. Well, we were going to be going right through Rochester on our way to St. Paul. So while I was replying, I let him know we're going to be coming through there the next day around noon. So it worked out to where he and his wife were able to join us for lunch. And if you're listening, I want to thank you so much for your hospitality. And as I've told you guys before, it's always great when I get a chance to meet you and have a talk with you. Y'all are always so fascinating to converse with. I've got a little clip of him that I'll plug into the end of this video, along with a few little excerpts. I didn't do much of a video on our trip up there because it was just so busy the whole time, but it was cold. We took Dollar with us, and I can't thank the Love truck stops enough for having those little doggy parks. She needs to be able to run around without a leash on her at some point on the way up there. And that's a long trip. It's 856 miles just to Cedar Rapids. And then we went on up to Guttenberg the next couple days and stayed there. And that's another hour and a half, I think, from Cedar Rapids. While I was going through St. Louis, I decided to call Cast Iron Gypsy, stop by and visit with them a second on my way through, and plug her into this video too, but somebody wouldn't answer their phone. But honestly, I was crunched for time anyway. It was going to be very hard to stop for any long period of time. Now I'm fixing to scribe off a center line once I strike the top of this mold off. And that is to hold my position as close to center as possible on that sprue as I push it into the mold. Keep in mind that I do have a solid cast runner system down under that, and I don't want to hit that. And it needs to be as close to the middle as possible. And the way I establish that is I just take my tapered sprue cutter and I just hold my finger like a scribing gauge on woodworking, and I use the lip of the sprue cutter to mark my sand. So the bullet pins did their job. They kept the upper cope side patterns mounted rigidly in the sand. They didn't fall out. And on this side of it, I don't have to worry about the bullet pins. I just can't forget to pull those out when we go to do the cope side. Now the runner, I don't show cutting the runner. I started showing where I'm going to start the path of it for filling the mold from the sprue hole there. This is why I can't go ahead and cast that in there, because I would hit that with the sprue if I had that runner already cast. So I cut that part by hand. I have cut the sprue directly down the middle. I stopped doing that, and because of one reason. The crucible needs to be on the very edge when I'm pouring in order to keep that stream low. I don't want any more biofilm going down that sprue than possible. If I were to try to pour from the very middle of the mold, coming straight down through the middle and distributing the iron, it would suck air and trained air all the way down through there, because I'd have that crucible at least a foot high, and a stream that high is just not, that's not going to be a good pour. Here I'm brushing down the, well, there I was brushing down the radiuses. But anyway, that's going to go all the way to that sprue hole, and I'm turning it up on edge. I just work better that way. I can keep a steady hand and focus on not channeling into the runner system. Earlier, as I was talking about the thickness of the cross-sectional wall thickness of the casting, I'm going to go ahead and beat you to the punch. Somebody's going to be chiming in saying you need to be using phosphorus for these super thin walls. If this was artistic pieces, you would be correct. But we don't want to do anything to compromise the integrity of the iron. We've got good quality iron going in these castings already, and I don't want to go taking any chances messing with this recipe. For those of you that don't know about phosphorus, it was used many years ago. As a matter of fact, there was jewelry that was very popular back in the 1810 to 1840 over in Europe. It was called Berlin iron jewelry, and you can see some examples here. Very ornate work, and the trick to this was to add phosphorus to the iron to create the fluidity that flow into the smallest sections of these pieces of jewelry. Now, as I just said, phosphorus is good for certain things, but it's not good for strength. Okay, so we're going to pull the pins now. They just slide right out. Oh, by the way, if you ever need a tooth pulled, I'm your man. The circular grooves on those bullet pins are fixing to be utilized right here, as I cannot extract this with these pliers. So I'm going to have to stick a screwdriver in that circular groove and pry against it. My hand isn't bleeding, by the way. I was helping my dad earlier change out a starter on his tractor. It was a rebuilt one, had a fresh coat of that cheap paint on it, and it didn't mix well with the diesel that was dripping all over it. But we're getting very close to setting the cope in place. All I got to do is cut the pouring basin on the back side, and I'll do that off camera as well. And I also need to brush the edge brakes where the riser intersects are. I don't want any possible debris washing into the casting. So I've removed all 4 pins. Now it's safe to remove the patterns. As I said, if you try to do that first, you'll pull huge plugs of sand up with it. And at some point, I'm going to forget. I just didn't do it on this video, but it'll happen. I mean, shoot, I've left patterns in the mold and poured before. Match plate. I know somebody's going to be saying I should be having all this mounted on a board. We've already been there, done that, didn't work. I wasted a good 2 months making up the board, getting everything just right, and I was not able to successfully pull this from the mold without tearing letters off and other big plugs of sand. I can not do this manually with a board. Now, once we get the addition made, we have a slab, I don't have to worry about losing all my sand on the floor, then we'll start doing this on the machine, but not until then. I have a lot more dexterity and precision in pulling patterns individually from the sand by hand than I do with a big board right now. Now, I vent these directly on the pattern. I put 3 vents in here. 2 may be sufficient. 1 may be sufficient. None may be sufficient. I'm not going to chance it. There's too much work going into these molds to keep my fingers crossed that everything's going to fill out without having to do any more work to it than I have to. Being consistent is very important with mold making, as well as anything. Whether it be right or wrong, it's a lot easier to narrow down the problem and solve it. A good example is a machinist. They, you're using your friction thimble to check these parts, and then the guy on the second shift comes in and he's cranking down on your mics like they're a C-clamp or something, and it makes whoever's having to follow up on your mistakes pull their hair out trying to narrow down what happened. So we're fixing a brake iron. It is dark outside. You guys that are so thrilled over this time change, it causes problems for me. I have to run all the lights in the evening time if it's not on a weekend. I always try to make sure I have my servings ready for the ferrosilicon. Alright. And I just stack them all up in these little bitty red Solo cups. I try to always have this kind of stuff already done. You don't want to be doing this when you're trying to pour. You don't want to be getting the furnace up to temp, adding your iron, finally have your crucible ready to pull, and then realize, oh crap, I don't have any of this readily on hand. So it's best to always do a check off and make sure you're more than ready. Man, that's some good water. Well, Dollar and I are on our way to Iowa. We got a 12-hour trip ahead of us. And she is ready. Aren't you, girl? Got you a bath this morning. It still stink, but... Well, we made it to Perryville. Dollar is doing well on the trip. I was concerned, but as long as she's got that seat to herself, she's good. All right, Dollar, who's driving here?
Continue on US 52 north for 4 miles.
I wanted to introduce you to a subscriber of mine. His name is Dave Richards. Yes, the Dave Richards.
Dave Richards, yeah.
But anyway, Dave and his wife, she and my wife bailed on us. They were too cold. We're way up here in Rochester, Minnesota. Anyway, Dave also has a channel. Dave, you want to tell them what it is?
It's the Design Click Build blog on finewoodworking.com. And it's about using SketchUp primarily for woodworking related stuff, but also for other things.
Wow.
So,
as I've always said, I enjoy meeting subscribers, and it was awesome to get to meet you and your wife.
nice to meet you too. I really enjoyed this. This was great.
But before we freeze, we're going to go on.
Well, yep.
But I want to thank you for the hospitality y'all shared here in Rochester.
Absolutely our pleasure.
It's other than the weather, it's lovely up here.
Yeah.
So,
I'm ready for spring too.
Yeah. That's a brown and short.
What it was.
Trying to get the camera to focus here where I can see it better.
I used to use that up there all the time because you can bring it right down to within a thousandth of an inch with it.
Right. The last video that you were just watching, that was my wife's grandfather. He had some stuff he was wanting to show me in his shop. He's got everything. As we were talking about the brown and sharp surface grinder, there is a specialty grinder in the middle between it and the Sheffield lathe. He's got a specialty grinder just for grinding scale weights. He worked with weights and measures. There was one particular thing that did not go with any of that stuff in there, and it's something I've been looking for years, and he happened to have it. And it's going to be used to tell me what's this mesh size of this sieve. This is just a cheap old Walmart sieve, mass produced, and I need a bigger one. I need to find out what size screen that is, and from there I'll be able to order the screen and make my own. We're going to start by sieving some sand with this into the bucket, and I'm not going to do a whole video on this, but we'll get about a pound of sand in there probably. Make sure that any sand in this bucket goes through the sieve first. And then I'll show you this contraption. Yep, that's about it. Check out my paint shaker. Okay, that is not a paint shaker. This is a sieve tester, and it's made by Gilson Company, and these are test sieves made by the T&S test sieve company out of Chicago. Each one of these have a plate on it that gives the wire size opening, and it gives you the number of the sieve with that. So I can tell a company that I want to order screen through that number, and they can send me that exact size. Now it starts from the biggest screen all the way down to this bottom pan. I can't see it from here. The opening is almost 6 thousandths, 5 thousandths, 9 tenths. Next sieve up is 11 thousandths, 7 tenths. Next sieve up is 16 thousandths, 4 tenths. Then 23 thousandths and 2 tenths. And then from there it is 46 thousandths and 9 tenths. And then this one here, I believe it is, it's in millimeters, 19.1. Huh. Now these aren't. These are in inches. That's millimeter for some reason. These were used by the highway department most of the time, and I'm pretty sure some foundries use these for checking their fineness in the labs. Any of you guys that worked in the labs at any foundries, please chime in if I'm right on that. I'm assuming they had a way to test their particle size in the sand. They should have anyway. I am thrilled to get this. I won't tell you how much I paid for it. It was practically given to me. And I won't be selling it. It's just nice that I have a set of these. I've been wanting, as I said, I've been wanting at least one test sieve of a particular size just to validate what I got sometimes. And when you go on eBay and if you look up and find one of these on eBay, they're several $100s per pan. I got the whole set along with the shaker. So, and the shaker works on a timer. You just set your timer from anywhere from 1 minute to 15. And I was going to show this to you after I cleaned all these up. And then I realized that's never going to happen. I don't have that kind of time on my hands. Now, if somebody else wants to come out here and clean it up for me, I'll be more than happy to let you do it. I'm going to show this in operation, and we're going to find out what size sieve that is that I'm using. But we're going to start by pouring this sand down in here. And I know for a fact it went clean through that screen. Then we're going to cap it off with this brass lid. Slides down in there. And then from here, I just push down in the middle, tighten these knobs, snug that up. And from here, I just turn the knob. It says to turn it past 4 minutes and then come back to 4 or under. So I'm wanting to shake this for 1 minute. Alright, I had to keep putting it back on the table. There's a reason for these mounting holes, I guess. So let's see what we got. Alright, so we'll take the lid off. Well, I don't have any sand on this one, so I'm going to just turn it over and set it in that order on each piece. I got one piece here. I don't know how that worked its way in there. And it's starting to catch a few particles, but it doesn't look like that's the majority. No, so I wouldn't count this. Alright, so it looks like the majority of our sand got caught on this mesh and that mesh. So with that said, alright, so this is going to be finer down here than this size. So let me get my pail. And this mesh is 16 thousandths. That mesh there is 11 thousandths. I must have, based off the majority of the sand stopping on this one, I must have, let's see, I need to be able to clean these up better where I can read them. Uh, 420? Huh. Somebody was smoking pot way back then. Let me study. I can't see that tag over there. I can't read what that's. I can read the number, but I can't read the. And that was a good idea. I can't read this one either. It looks like it says opening. 1 point. This is millimeter. And that is inches. Okay, alright. Yeah, and on this one it's inches over here, millimeter on that side. Somebody was smoking pot that day and got this on backwards, I guess. I'm assuming, if I'm reading this right, that number says 39. So that's a number 39. No, it's a 30. Okay, 30. That's a 30. This is a 16, which was bigger. That goes down to a 30. So it's going to be a number 30 sieve. It stopped on this one, which is a number 40 with a 16 thousandths opening, or a 420 millimeter. Alright, I can remember 420. Alright, so let's break it on down, see just how, oh, it goes even finer than that. So, alright, so it goes from a number 40 to, it'll go through to a number 50. I better just keep pulling these pans off, huh? That held quite a bit in there. In the number 50. But we had quite a bit escape and go into the number 100, which is 6 thousandths. Alright, I went ahead and set the timer for a full 5 minutes to see if this will shake it down better. I've never used one of these contraptions, so I'm learning just like you are. I am seeing a difference. Yeah, I would say it's safe to say that this size is what our sieve is, which is a number 50 at 11 thousandths opening. And this sand went through a sieve size of 6 thousandths. And it just so happens I have some 5 thousandths sieve wire, stainless steel wire. Anyway, that's it right there. It'd be nice if I could get all my facing sand to that consistency. But anyway, I just wanted to show you guys my test sieve. Show you how to determine what size mesh screen you've got in a certain sieve. I guess I'm going to make a two-part video out of this. Cut this off here. I got some other things I'll include in the other video that I brought back. Well, I didn't bring back. Jason McDonald of Jason McDonald Trucking, he and his dad come up here last week and they delivered a furnace. I didn't get that on video. I should have. It's one that Keith Rucker found at Iron Fest. I haven't had a chance to look it over, see what we got to do to it to get it to work. But it's a nice furnace. It's made by, no, don't get me the line, I can't remember. You know what? While we've got this out, let's see what the good old Mississippi red dirt does in this thing. That's a rock. I don't know what that was, but I got a lot washer. I didn't know all this junk was in that dirt. I thought I had good native dirt here. Well, I'll be. That, my friends, is sawdust. Is clay. It's not clay. So you guys tell me, what is in this that makes Mississippi dirt red? I keep Dollar out here at the shop with me now, and I keep her tethered to a bucket so she doesn't go far. Do you, Dollar? Let's go for a walk. You want to go for a walk? Let's go for a walk. Come on, let's go. Yeah, there you go. It works. It keeps her here by me anyway. But I hope y'all have a good day, and I'll try to have the other part of this video ready and loaded next week. I'm trying to, we're gonna finish grinding and stress relieve these 6. I'm also going to be making some more, and I may go ahead and do that modification I was talking about and make these castings a tad bit thicker. And if I can get a batch of those poured in time, we'll go ahead and include that in the video. But at the same time, Keith just told me we sold the last 9-inch straight edge, so I got to get some more of those made up as well. Dollar, you want to say goodbye? Huh? You want to say so long? No? You hate to let them go, don't you? Alright, we'll talk to y'all next week.